Your AI agent is not stupid because the model is weak. It is stupid because it cannot remember where anything is, and ByteDance just open sourced a project that basically says the quiet part out loud. Most agent memory is a mess. Your documents are in one vector database, your preferences are in a memory layer, your coding rules are in random markdown files, and when the agent gets the wrong thing, you usually have no idea why. OpenViking is trying to fix that with an idea that sounds boring until it saves you real money. It turns context into a file system. Memory, resources, and skills all get paths. The agent can browse them, search them, read summaries, and open details only when needed. And the retrieval path is visible. So instead of a vector database throwing 5 mysterious chunks into the prompt, the agent can show the path it took to find the answer. That is not flashy. That is what stops software leaking money. The numbers are not subtle either. In OpenViking's own Locomo benchmark, Claude Code went from 57% memory accuracy to 80% with OpenViking attached, while OpenClaw and Hermes both landed above 82. And input tokens dropped by as much as 91%. Those are vendor numbers, so do not treat them like holy scripture. But even if you cut the hype in half, the direction is hard to ignore. The real problem with agents in 2026 is no longer just a model. It is the context layer underneath the model, and I think OpenViking is one of the first open source projects that names that layer properly, not as a prompt trick or a vector store, as infrastructure. Hey, don't forget to like and subscribe for more like this. Now, back to the video. The easiest way to misunderstand OpenViking is to call it a vector database. It uses vectors, it does retrieval, it can search semantically. So from 10,000 feet away, it looks like it belongs next to Pinecone, Wavy8, Chroma, Qdrant, or any other place developers throw embeddings. But that is not the interesting part. A normal vector database is basically a very fast similarity machine. You give it chunks and embeddings, you ask a question, it gives back the chunks that look close. That is useful. It is also not how developers understand projects. When you open a codebase, you do not ask for the 7 most semantically similar paragraphs to payment bug. You look at the tree, open the file that probably owns the behavior, skim the surrounding code, and then go deep. OpenViking is built around that map. Everything gets organized under a Viking URI, resources, user memory, agent skills, and sessions all get a place. The agent is not just fishing in a pond of loose chunks, it is walking through a directory structure. That one change is the argument. Agents do not only need facts, they need orientation, they need to know which project they are inside, which person the memory belongs to, and which rule is global. Vector search is good at closeness. It is not naturally good at ownership, hierarchy, or explaining why the answer came from one place instead of another. OpenViking's bet is that agent context should not be treated like a bag of paragraphs. And honestly, I think that is the right mental model. The best agents already behave like junior developers who can read, so why are we giving them memory systems that look nothing like a workspace? The core trick in OpenViking is its 3-layer context model. L0 is the abstract, a tiny summary for deciding whether a directory is relevant. L1 is the overview, big enough to understand what is inside without opening every file. L2 is the detail, the original file you load only when the task deserves it. This sounds simple because it is simple, and that is why it is good. Most bad RAG systems fail in one of 2 ways. They stuff too much into the prompt and drown the model, or they retrieve tiny chunks with no surrounding context. OpenViking tries to sit between those failures, search high, plan in the middle, read deep only when necessary. If the agent is looking for API authentication details, it can find the authentication directory, read the overview, and open the oath file only if the task is actually about oath. That is how a person works. And when context windows are huge, people forget why this still matters. They say, just throw more tokens at it. That is how you build an agent that costs more and gets dumber at the same time. Long context is not magic, it is a bigger room, and if the room is filled with wrong docs, duplicate summaries, and stale preferences, the model still has to find the answer. OpenViking is interesting because it treats retrieval as navigation, not just recall. The agent is not trying to remember everything. It is trying to know where to look. That is a much better job description. Now, the benchmark numbers are the part that will get clipped. OpenViking says version 0.3.22 was tested on long conversation memory and multi-turn agent tasks. On Locomo, OpenClaw went from 24.2% accuracy to 82.08 with OpenViking. Hermes went from 33.38 to 82.86. Claude Code went from 57.21 to 80.32. That Claude Code number is the one I care about most, not because it is the biggest jump. It is not. I care because the baseline is not completely useless. Going from 24 to 82 tells you the old setup was probably thin. Going from 57 to 80 while also cutting input tokens by 63% is more interesting. That suggests the context system is not merely adding more memory, it is delivering less junk. And that distinction matters. A lot of memory products make demos look better by storing more things. User likes TypeScript, user prefers dark mode, user works on React, cool. But if you keep adding facts without structure, you eventually build a junk drawer with embeddings. The agent remembers more and understands less. OpenViking's strongest claim is not that it stores memories, it is that it stores context in a way the agent can inspect and traverse. The Tau2 bench numbers are smaller, but probably more realistic. OpenViking reports task success rising by 6.87 points in retail and 11.87 points in airline. Better memory gives the agent enough past experience to make fewer dumb moves. That is what I want from this category. So how does OpenViking compare to Mem0? Mem0 is probably the easiest comparison because it is very direct. You add memories, search memories, and get useful facts back. It can use vector storage and graph relationships, and the API is much easier to explain to a normal application developer. For a lot of products, that is enough. If you're building a support bot that needs to remember a customer, prefers email, and had a billing issue last month, Mem0 makes more immediate sense. It is a memory layer. OpenViking is trying to be a context database. That means it wants more responsibility, it wants memories, resources, skills, file system commands, summaries, retrieval traces, and session commits turning into long-term memory. This is both the advantage and the danger. The advantage is that it matches the way agent work grows. The danger is that bigger mental models are harder to adopt. Mem0 feels like something you can add to an app on Friday. OpenViking feels like something you use when the context layer itself has become part of the product. That is not a criticism. It is the category line. If all you need is user memory, OpenViking may feel like bringing a storage system to a note-taking fight, but if your agent needs to remember the user, browse docs, follow team rules, recall previous failures, and share skills across tools, a simple memory API starts to look too small. My take is this: Mem0 is the better default for product memory. OpenViking is more interesting for developer agents and long-running agent systems because code agents need a working map of a changing workspace. Zep is the more dangerous comparison because Zep has a very strong idea too. It turns messages and documents into a temporal context graph. It extracts entities, facts, relationships, episodes, thread summaries, and user summaries. That is powerful. For many applications, graph memory is probably a better fit than a file system. People, accounts, dates, commitments, and changing facts are graph territory. OpenViking is not trying to win that exact fight. Its strongest shape is not a relationship graph. Its strongest shape is a navigable context workspace that makes it feel more developer native. A project has folders, docs have sections, skills have names. When an agent is building software, the file system metaphor is not cosmetic. But there is a trade-off. Graphs can represent relationships that folders struggle with. A bug can connect a customer, a commit, a deployment, and a support ticket. So OpenViking cannot pretend hierarchy solves everything. The directory bias is good for clarity, but limiting for messy business memory. So my opinion is this: Zep is the stronger fit when your app is mainly about evolving relationships. OpenViking is a stronger fit when your agent needs a place to work. Letta is different again because Letta is a stateful agent framework, not just a memory store. Letta says, build your stateful agent here. OpenViking says, give your agents a shared context file system. That second idea is more portable because developers will not standardize on one agent runtime anytime soon. Claude Code for one repo, Codex for another, cursor inside the editor. The painful part is that every one of those tools starts from zero. OpenViking is trying to make the memory and skill layer survive the tool churn. This is where I think OpenViking gets unusually developer-friendly. Observability. I know that word sounds like dashboard wallpaper, but with AI agents, observability is the difference between debugging and guessing. Traditional RAG often fails like this. The answer is wrong. You inspect the prompt. One chunk is stale. One came from a document you forgot existed. And now you have to reverse engineer why the retrieval system chose those chunks. Was the embedding bad? Was the chunk too small? Was the query vague? Was the agent even searching the right namespace? OpenViking's retrieval trajectory is trying to expose that path. The agent does not just hand you the final context, it can show the route. That is a huge deal for teams, because production agent bugs will not look like normal bugs. They will look like the agent made a reasonable choice from bad context or a bad choice from reasonable context. You cannot fix that with a better prompt. You need to see where the context came from. You need scopes, paths, levels, and a way to know whether the agent loaded an abstract, an overview, or the full source. This is why I am more excited about OpenViking as a debugging tool than as a memory tool. Memory is the feature people understand. Debuggable context is the feature developers will actually need now for the uncomfortable part. OpenViking is early. The package metadata calls it alpha, and the main project license is AGPL 3.0. That is not automatically a problem, but it is something companies will notice. AGPL is not a casual license for every commercial code base. Also, a context database is a bigger operational commitment than a library. You now have ingestion, summaries, embeddings, re-ranking, sessions, memory extraction, namespaces, permissions, freshness, and stale-generated summaries. OpenViking has ideas for this. The docs talk about sidecar metadata, freshness, protected fields, stable sampling, and parent summary generation. That tells you this is real infrastructure. You do not add it because you watched one impressive demo. You add it because context has become expensive enough to deserve a system. And the hosted OpenViking service creates another question. Do you want your agent's long-term memory, project docs, and skills attached to a ByteDance Volcano engine service? For some teams, the answer may be yes. For others, that sentence alone will end the meeting. The open source story helps, self-hosting helps. Agent memory is sensitive. It contains what users prefer, what projects contain, and what the agent learned. So my take is not, everyone should use OpenViking tomorrow. My take is that OpenViking is pointing at the right problem, and that problem is about to get expensive for everyone building agents. Here's the opinionated part. Most agents today are stateless interns with massive reading speed. They can do impressive work inside one session, then you close the tab or switch tools, and they become weirdly forgetful again. The industry keeps trying to fix this at the model layer. Bigger context, better models, longer reasoning, all of that helps, but it does not solve the storage problem. Agents need a durable external brain that is organized enough to be trusted. They need a context layer with ownership, hierarchy, recall, inspection, and controlled depth. OpenViking is one of the clearest attempts I have seen at that layer. I do not think it replaces vector databases. Under the hood, retrieval still needs vectors. I do not think it kills Mem0 or Zep. Those products have cleaner stories for specific memory use cases, and I do not think it replaces Letta, because agent runtimes are a different level of the stack. But I do think it makes plain vector RAG look under design for agents. That is the real comparison. If your agent only answers questions over documents, a vector database plus decent chunking may be enough. If your agent needs to work for days, remember users, reuse project knowledge, share skills, and explain its context, flat chunks start to look primitive. The question becomes, do you want retrieval or do you want context management? Those are not the same product. OpenViking is betting developers will eventually notice. The most interesting thing about OpenViking is that it is not glamorous. It is not a new model. It is a storage shape, and storage shapes decide what software becomes possible. Relational databases made application state normal. Git made history normal for code. Vector databases made semantic retrieval normal. OpenViking is trying to make agent context normal. That might sound too big, maybe it is, but the need is real. Developers are already running multiple agents with scattered rules, docs, tickets, source files, and preferences. They already waste tokens because every tool has to be reminded of the same things. OpenViking's answer is simple enough to be compelling. Put the context somewhere real, give it paths and layers, let agents browse before they read. That is the bet, and I think the bet is right. Maybe OpenViking itself becomes the standard. Maybe it does not. Because agents that cannot manage context will always feel like demos. Agents that can manage context start to feel like software. And that is the line OpenViking is trying to cross.